Thank you, Jennifer, and welcome everyone to this month's Connect with Remedy webinar. During this session, if you have any questions, you can ask it via the Q&A pod within the WebEx, and our panelists will be able to answer those questions. This webinar is being recorded and will be posted within a week of today's live event. And at this time, I'll turn this over to Tim Cannon, and he will take us through Event-Driven Discovery Framework, a deep dive. Tim?
Thanks, Greg. Hi, everyone. I'm Tim, and I'm a developer here in London on the BMC Discovery team. And thanks very much for joining us today. So, what have I got planned today? Well, I am going to start off the session today by introducing the BMC Discovery product, because I'm sure there's a few of you at least that have not come across it, not sure what it's used for. And once we're all up to some sort of level of understanding, I'm going to jump in and start talking about the event framework within BMC Discovery. I'm going to try and explain the concepts that we had when we were implementing the feature, and also the concepts that you need to bear in mind when you're making use of the feature. And then I'm going to go straight into a live demo, fingers crossed for that. But because I always think it's so much easier if you learn by example and you see things being used in front of you. Then we're going to go back and talk a bit more about some more details about events in BMC Discovery to try and fill out some of those other details. I'm going to just touch on a built-in feature, which is the vCenter event source. We'll see that coming up. And I'm going to finish up with another live demo, and then we'll have some questions. So really, I'll be happy if by the end of this, I've managed to get across the key concepts that, as I say, that you need to bear in mind if you're making use of event-driven discovery in BMC Discovery. And also, if I've got you to start thinking how you could make use of this feature in your environments to solve your specific business requirements. Now, I should probably warn you, this is going to be a pretty technical webinar today. The nature of the events feature, as we'll see in a minute, is that you interact with it by talking to the REST API and by writing patterns in a pattern language that our product supports. And so you'll be writing code, and I'll be showing some of that code today. So I'll try and talk through every stage what I'm doing and explain all the bits of the code and the calls that we make to the REST API, assuming basically that none of you have interacted with it before. So let's start off with an introduction to BMC Discovery. What is it? Well, our product, it scans your estate and it tells you what you have, both infrastructure, servers, storage systems, network devices, and also the software that makes up your applications and services that are running on top of that infrastructure. And crucially, we discover the dependencies between those services, that software, and all those applications. So essentially, all you do is you give BMC Discovery an IP address range, and our product goes off and automatically scans all the endpoints within that range, and it reports back what it has found there, whether it's servers, storage systems, as I say, devices, and it interrogates those automatically to find out what's running on those and what the makeup is of those things that it's found at the end of those IP addresses. And it stores all of the information in a graph database, which is then accessible via a powerful browser-based UI as well as a REST API that we're going to see. And we're going to see both of those actually in action today. Now, we discover your assets using a whole variety of different protocols, depending really on what we find at the end of each IP address that we're scanning. So if we think we've located a Linux server, we'll probably try and use SSH to connect to it. If we've found a storage system, we might try the WebM protocol and SNMP for network devices, and there's WMI for Windows access, that sort of thing. And what you do is you configure the BMC Discovery product with some credentials that we will use then, for example, SSH credentials that we'll then try to use when making an SSH session to a Linux server. And once BMC Discovery has that SSH session, it will run some commands that you might be familiar with running on the command line, for example. So to get a list of processes running on the server, it might run a PS. But all the information that we gather during the scan is stored in this graph database. And you'll hear me talk about records in that database today, and we refer to them as nodes in this graph database. We store all that information. Typically, the graph database contains millions and millions of nodes if we're scanning fairly large estates. And then it's available for you to interact with through the user interface or that REST API. Now, we can also scan, as well as your deployments on-premise in your data centers, we can also scan any deployments you have in cloud. So instead of an IP address, you can put in the cloud provider that you're hosting your services in. So for example, we can interrogate the AWS or the Azure cloud APIs. For today, though, we're going to be talking about IP addresses. And another thing just to point out is, as well as using the user interface to explore all the information that we've discovered, we can synchronize to a CMDB, synchronize the discovered data. Now, another thing I should point out, because this is going to come up, is the way you customize BMC Discovery. So out of the box, we ship with what we call patterns, and these are little bits of what we call knowledge that let BMC Discovery know how to interpret the raw data that it's found by connecting to endpoints, whether it's servers or storage systems or devices. So for example, we'll ship with a pattern for the Apache web server, and I'll actually show you that one very shortly. And so that pattern tells BMC Discovery that when it finds a process called HTTPD, which is the main process for the Apache web server, it's found an instance of running Apache web server, and we'll create a record, a node in that graph database I mentioned. But we don't know about any proprietary software, obviously, that you have in-house, that you've written and that you've deployed in your estate. So you can customize BMC Discovery by writing your own versions of these patterns and uploading them. And that's going to be one of the key things we do today, because that's one of the ways you interact with the event framework. So why would you use something like BMC Discovery? Why would you need it? Well, there's actually many use cases. At the very basic level, it's to understand your infrastructure so that you know what you have, whether it's for audit purposes or to identify the business impact of threats, but also to understand the makeup of the services that are running on your infrastructure. So you can do things like validate changes that you're expecting to have been made via some change process to your services, but also expose unauthorized changes and understand the impact on applications if you're handling tickets or you're trying to decide the impact of outages, because we've got all the rich data about the dependencies between applications that we've discovered. And you can also manage the cost if we find unused or underused infrastructure. And typically people configure the product to scan their environment a few times a week or once every day. Really depends on how large their environment is and what their requirements are and how often things are changing. And the final thing to mention in the introduction to our product is the term appliance, because the way we are deployed, our software is deployed, is we are deployed on-premise, so our customers deploy our software, but we don't give you an installer that you install on a pre-configured Linux or Windows server. Well, we give you a whole virtual machine. So this is built up from a Linux base with packages and then our software put on top and controlled, so we've got exactly what we want running and nothing else on there. That way, and we refer to it as an appliance. It's a virtual machine, though, that you can just start up. So that way, there's none of the headache of trying to worry about interactions or bad interactions with various versions of third-party packages, binaries that you've got lying around, or slightly different service packs for operating systems. So we find that this means that we have a really, really quick time for customers to pick up the product and start using it, because all you need to do is you download a virtual machine image, you start it up, you log into that web UI, and you put in an IP address, and we scan your estate. And we also pride ourselves on having pretty easy upgrade processes where you can just upload the new version into the user interface and we'll update. So yeah, that term appliance is probably one to bear in mind, because I'm going to mention it a few times today. Okay, so hopefully that gives you a basic introduction to the product, and we'll be using it, particularly the user interface, throughout today's demo. Right, so we tend to do maybe 1 or 2 major releases of BMC Discovery every year, and we also release service packs and patches throughout the year. But at the end of last year, we released BMC Discovery 11.1. And one of the main themes of that was to open up the product, so to make it easy for integrations to be written against BMC Discovery. And there were two main stories in that theme, and the first of those was we introduced for the first time the REST API. So before 11.1, you could interact with the user interface, and we had a variety of command line tools that we built up over the years, but we wanted to offer a versioned and consistent API that you could build integrations on and rely on to be backward compatible and to grow over time, so that you could write client applications in any language that can talk to a REST API over HTTP, which basically is every OS and every library and framework and language under the sun these days. So that was the first thing that was released in 11.1 that really opened up BMC Discovery. And then the second thing, which is what we're going to be talking about today, is event-driven discovery. Event-driven model updates is the term I'm using there, and we'll see why I'm talking about model updates in a minute. But it turns out that in order to make use of event-driven discovery, you need to also interact with the REST API. So we'll be talking about both of these things today. So what is this event-driven model updates thing? What are we talking about today? Well, as I mentioned, our customers typically scan IP ranges, and they schedule scans to run every couple of days or every day. And as we scan IP addresses or those cloud APIs, we store a model in our graph database of what we found, and that model includes all the servers, we call them hosts, all the file systems on them, all the network interfaces, and then the software and the databases and all the interactions between them. And as we rescan the same endpoint, as things change, we'll update our model of the world. So you have this huge graph, which is a big database that you can view through that user interface, and it's our model of your estate, of your environment. But we're not a monitoring tool, and we're not aiming to notify in real time of any changes to running software or things like server availability. So there's a gap where sometimes you, as a customer, will know from an external source, external to BMC Discovery, that something in your environment has changed, and you want to push that knowledge immediately into BMC Discovery. You don't want to wait for the next scheduled scan. And this is where events come in, external events, to give them their full name, because you know that something's changed in your environment, and you want to inform BMC Discovery of that and get Discovery to update its model of the world without having to wait for the next scheduled scan that would find that change. So here is the workflow for getting events into the system. And I'm going to keep coming back to this throughout the whole webinar today, because if I manage to sort of to go over this enough and get you to remember one thing, it's these three stages, because this is all you really need to get your head around to make use of the events feature. So you know that something has changed in your environment, and you want to send that knowledge into BMC Discovery. So the way you package that up is in what we're calling an event. And the way you send that event into our system is to use our REST API. So it was lucky that that came out in the same release as events. For those of you that are familiar with REST APIs, POST requests are the way that you send. They're the type of request that you would send in when you're making a change to a resource inside the API. And GET requests are things that you do when you're retrieving some existing resource. And then there's typically puts and patches for updates to existing resources, and there's deletes, and you can guess what that does. So in this case, you send a POST request to our API, and you send in that POST request an event, and the event encapsulates your knowledge of what's changed in your environment. So that's stage one of the events workflow. Stage two involves something called an event source, and we'll see that in just a minute. But as a user of Discovery, you configure an event source using the user interface, and the event that comes in through the API is targeted at a particular event source, and then the event source creates a record of that event that's come in. That's fine, but nothing interesting has happened yet, and that's when the third stage comes into play. And this is really the interesting stage. So you write a pattern, and this, we're going to see patterns and I'll explain what that means, but it's a little piece of code. You upload it to BMC Discovery, and the pattern triggers, and the code executes whenever an event of a certain type arrives in the system. And in your code that you've uploaded in your pattern, you get to examine the event, retrieve any data that came in the event, typically data about the change that's happened in the environment, and then make use of that data to tell BMC Discovery to update its model in a certain way. So, as I say, I'm going to keep coming back and talking about these three stages because that's what you need to just sort of understand really if you want to make use of the feature and understand it, understand what we're trying to give you with this feature. So, stage one, you interact with the API, you push in some events based on your external knowledge of something that's changed in your environment. You push in an event into the system. Stage two, an event source accepts the event, and stage three, a pattern which you've previously written and uploaded triggers and updates BMC Discovery's model of the world, model of your environment. Right, so let's do a demo because I think it will be a little bit clearer if you see one of these workflows being run through end to end. Now, before we start showing you code, the demo involves more than one machine, so I thought it would be useful just to explain what you're going to be seeing and what's interacting with what. So there's actually three machines that are in play in this demo. So at the top here, we have the BMC Discovery appliance. So remember, this is the term we give to the deployment of our product in your estate. It's a virtual machine. And normally, as a user of it, of our product, you wouldn't really worry about all the components that are running on it. You would just connect to the user interface in your browser, or maybe to the REST API if you're writing a client application. And I've highlighted those two components and left everything else just as calling it core components. But I'm pointing out that there is a BMC Discovery appliance, obviously, in this demo. This is a demo appliance I've set up and I've got running. Now, at the bottom right, we have a client machine. And this is just running my browser. So this is just typically going. This is the same as any of your users inside your premises that are connecting using their browser on their workstation to the BMC Discovery instance. And through the user interface in that browser, you can browse around all the data that we've discovered. And also in this demo, we'll see how you can use the user interface to upload patterns. And then finally, there's a third machine on the bottom left over there. And so this machine is the client of the REST API. It's a different machine, so this would typically be running the script or the program in any language that you write to interact with our API, and for events, you're talking to the endpoint, as we call them, that you use to send in events into the system. And we'll see all the different endpoints you can talk to the API on in a minute. But for this demo, I've set up a completely separate Linux machine, and we're going to use a tool called curl, which I'll just introduce in a minute. And we're going to talk to the REST API running on the appliance. So I'll try and point out which of the machines I'm on at any one time. Okay, so let's go and have a go. Here we go. So for those of you that haven't seen it before, this is the user interface of BMC Discovery. So I'm connected from my browser to the demo instance of Discovery. So this is the home page. You can see the status of the Discovery component at the moment and whether we're doing any scans or not. Here's some previous scans we did. And down here you can see data that's already been scanned and it's in our system, and there's over 300 hosts that I've previously discovered, and I can click through and I can see the hosts, and I can click through again, get a visualization of the hosts, and you get tabular form of the data. And we'll see a lot more examples of that as we go through. To start with, though, I'm going to go to the administration page and the event sources section here. So we need to create an event source. So this is that second stage, actually. We're going to do that first. The second stage of the workflow. We need an event source to receive the events. Now, hang on, there's already one here, but notice that's built in. So the vCenter event source is a special thing that's built in. You get that for free. Just remember that for now. I'm going to come back and talk about that. But for now, let's add an event source of our own. There we go. We'll call it webinar. And there we go. So now we have a new event source in the system called webinar. And just note that there's been no event sent into this event source yet. Okay, now, so that was the middle stage actually we've done already, the second stage of that three-stage workflow. Right, now we're going to go to the machine that was on the bottom left in that architecture diagram. So this is the separate Linux machine. It's the client of the API. So I'm on the command line here. Now, I'm going to be using a tool called curl. Probably lots of you are familiar with this, but this is a Unix command line tool that can talk a whole load of different network protocols. And for the REST API, we're going to get it to talk HTTP. So the REST API, the key things about the REST APIs in general, well, they're sympathetic to the HTTP protocol. So that means that the resources are accessed via URLs. You use the HTTP action as the verb to interact with them. I mentioned gets and posts. And you use status codes to indicate success or otherwise. Use HTTP response codes. And for the data that goes back and forth across our API, we use JSON, so that's JavaScript Object Notation. I'll point out a few other things, but if you're interested in more details of the REST API, there's a whole other webinar, and we'll provide a link to that introduces you to the REST API and goes through it in a lot of detail. So we're going to use curl, and let's just start by accessing this discovery instance. So the name of the running BMC Discovery instance on our network is that, discovery.calbro.com, and we're going to talk to this endpoint called API/about. It's the root, the top level endpoint in our API. You can call that, and you get back the version of the product running, so I'm actually running version 11.2, but also the API version, which is separate. We version the API separately in a backward compatible way, and so currently we're supporting concurrently here actually 1.0 and 1.1. Doesn't really matter. We're going to always go and talk to the latest version, but the events feature you see here was available in 1.0 and in BMC Discovery 11.1. I just happen to be running a slightly later version of the product, but it doesn't make any difference for this webinar. So that's the basics of using curl, but we need to do something useful now. We want to do that first stage of the workflow now. We want to send in an event into the system. So which endpoint, what's the URL I need to use for that? Well, if we go and have a look here I'm on docs.bmc.com, so all the documentation for BMC Discovery is publicly accessible. You don't need to log in. There's a whole section, there's various pages on using the REST API, and one of the pages, which is pretty useful, lists all of the different endpoints, as we call them, so all the different things you can do with the API. And you can see there's a lot of things to do with discovery, as you'd expect. You can put in a new discovery run, so that would be where you say, here, go and scan this range of IP addresses, or go and talk to this cloud API. There's a lot of other endpoints you then use to retrieve the data of the results of those scans. There's a lot of endpoints that you can use to explore all the rich data we've got, manage credentials down here. But the thing we're interested in, first of all, is this endpoint here. So it's /events, a nice simple URL, and it's a post request that we need to send in. And let's look at the details. So in the body of the request, we need to send in some JSON, and it's got two mandatory fields. So you need to specify the event source name. So remember, event comes in, it needs to be targeted at an event source. Well, we just created one, so that's okay. And you need to specify a type for the event. So what does that mean? You'll see what that means. We'll explain that in a minute. So let's go back to our command line. So using curl, you can use -x to tell it to send in a post request. Now, every request to the API, apart from that one we just saw, needs to be secured. You have to log in with a username and password to our user interface, and same for the command line tools. And as you'd expect, that to interact with the API, all requests are secured because you can manage your appliance, you can start scans, and you can retrieve data. So we use a standard authentication protocol called OAuth2. It's a standard protocol for REST APIs. The details of it, again, you can look at that webinar or read the docs if you're really interested. The key of part of it, though, is really that it's token-based. You get hold of a long opaque token, and then the token must be embedded in every request. Actually, I have set up here on my command line a variable called token, and that's an example of this long opaque token that you've got. It's a secret token that I've retrieved through other means. If I'm pretending here to be the developer of a client application that's interacting with the Discovery REST API, then I've been given this token from the administrator of that Discovery instance, and I'm allowed by using this token, I get to be authenticated, and maybe the administrator only gave me permissions to post events, maybe not to start new scans or whatever. The users going through the API are can be permissioned in just as a fine-grained way as through the user interface. But anyway, I've put the token here in a variable, so I don't need to keep typing it in. But I need to ask for a post request, and I need to pass that token in. So I want the authorization header. The token type is a bearer token, and that's how I'm going to pass in the token. So it's an HTTP header that's going to go in every request received from now on. Now, I need to pass in a payload. I need to pass those that JSON request. So -d, and then here's the request. So it's an object, and we saw that it has a source field, which needs to be set to the name of my event source we set up. We just called it webinar. Needs a type field, as we saw. What does that mean? Well, let's call it SetMessage for now, and we'll see why in just a minute. So that's all I'm going to put in the body of my request, and I need to target though. I need to target that endpoint that we saw. So all endpoints, apart from that top level about one, are versioned. And that's the name of the endpoint I'm targeting. So just check that curl, it's a post request, there's the header, and there's the payload I'm sending in. It's got a source and a type. So let's give that a go. And we've got back this long string here. Well, if we look at the docs again, it returns a unique ID if the event has been recorded. So it looks like the event has been posted into the system, and it looks like the event source has accepted it. Let's go and just check that back in the user interface. You might notice there, for this webinar event source, we now have one event that's been received in the system. So we can have a look at that. So the event source has just received the event, and it's made a record of it in our graph database. It's an external event node in our database. And it's just recorded the type of the event there and the source that it was received via. But that's it. So we've done stage 1, the REST API. We've done stage 2, the event source, but nothing else has happened. All we've done is we've created a record of this event, but nothing interesting has happened in response to the event. Well, that's where we need to implement stage 3, which is to write a pattern that triggers on this event and does something useful, updates our model of your environment. So what are these patterns I've been talking about? Well, let's have a look. So if we refer to them as part of the knowledge of BMC Discovery. So as I say, we release new versions of the product maybe a couple of times a year with whole new features in, but also we ship with, as you can see here, thousands of patterns that know how to discover different network devices and how to interact with different cloud APIs and how to recognize running instances of software, both of software that you might get off the shelf. But as new network devices come out and cloud APIs evolve and software is released, you don't want to be out of date. So every month we also release what we call a knowledge update. And this is a whole bundle of network device definitions and code to talk to cloud APIs, and also patterns that can discover new software every month. So here on this instance of Discovery, I've got a couple of thousand patterns that are running. They're all patterns that come out the box with the product. And if we have a look at just one of them, so let's use that HTTPD example, that Apache web server. So there's a few different patterns here that refer to the Apache web server. Here's the base one. So this is an example of what we call TPL. It's the pattern language. It's a little bit like Python maybe, but it's how you write your patterns. Now, this is a built-in pattern. It's particularly complex. You don't typically end up having to write patterns like this at all, but patterns have a certain structure if I go down to the bit that's interesting for us today, they have a name, the name of the pattern here, and crucially, they trigger on something. So this is a pattern whose job is to recognize and run an instance of Apache web server, and look what it triggers on. It triggers on a process being discovered that is called HTTPD. So when we connect whatever it is over SSH, for example, and we issue a PS command to get a process list, if it's a Linux server, well, if one of those processes that we discover is called HTTPD, this pattern will trigger. But what it says is actually that it triggers on a discovered process node being created. That's because as we discover processes in your environment, we record them all. We record all the raw data that we've discovered, and we call that a discovered process in our big graph database. And then this pattern's job is to trigger on that, and then what it does is a whole load of further gathering of configuration information about this Apache software, and then finally, somewhere down here, it will do this, which is to create another record in our graph database. This is a record of the actual Apache software, so we call it a software instance. So the pattern's job is to trigger on something that's been created, in this case, the discovered process, and this will be at discovery time, at time of scanning an endpoint, and its job is to gather some more information and then to create an instance of one of these software instances in our database. So that's typically what a pattern looks like that's doing something at discovery time. And you can write your own patterns. As I say, don't worry, they don't typically tend to be anywhere near this complicated. And in fact, in more recent versions of our product, you can often get away without writing patterns. You can use the user interface to point and click at a discovered process and say, hey, that's an instance of my piece of software, and we'll generate the pattern for you. But anyway, for interacting with the events framework, you do need to write patterns. And so let's show you an example of that. So here's one I've got ready for us. So it's a pattern. I've called it SetMessage. Its job is going to be to set a message on a person node, and I'll show you in just a minute what that means. But look, just like the other pattern, it triggers on something. In this case, though, it's not triggering on a record of a process that we found as a result of a scan. It's triggering on an event being created, on one of those external event records that we just saw. It's going to trigger on one of those, but only when the type of it is SetMessage. And there you go. That's why I use the SetMessage for the type when I sent in through the API. So if an event is created in the system of type SetMessage, this pattern will trigger. And here's the body. It's very, very short, a few lines of code. What does it actually do? Well, the first thing it does is it searches our database for these person nodes. Just remember that. We'll show you what that means. But it only searches for ones where the username of them is the username that came in the event. So this is important. The event that we trigger on has lots of information, because remember, the whole point of this feature is something's changed in your environment. You want to tell us about it, and you package up that knowledge into an event. And part of the payload of the event is going to be actually information about what's changed. In this case, it's a silly example I'm using. I'm not actually going to be updating any part of our model that refers to things that we've discovered in your environment, but rather this person node. And I'm going to be looking for a username that's sent in the event. And so we do a search for all the person nodes where the username is whatever the username was in the event. And if we find it, we then extract a second bit of information from that event here. We extract a message from the event. So we're looking for two bits of data in the event that we've triggered on, a username and a message. And then what we do is we set a message field on the user that we found, and we set it to the value of the message that came in the event. And this thing here, this line here, well, that just makes sure that the user interface makes that message field accessible. So I'll tell you what we'll do. We'll upload this pattern into the product, and then I'll show you these person nodes. So you go back to that knowledge page, and we can upload the pattern right now through the user interface. Incidentally, you can use the REST API if you wanted to as well. There we go. So the pattern's been uploaded. It's going through a compilation process now. It just takes a few seconds. But while that's happening, let me just show you these person nodes. So if we explore all the data, this is a summary of lots of the useful data that we currently have in this instance of BMC Discovery. I mean, our job is to discover things in your environment, and so most of it is the data is things like hosts that we've discovered, clusters, databases, software, network devices, that kind of thing. And so I've discovered over 300 hosts and thousands of software instances in this instance. But this bit down here is special. This metadata down here, this isn't stuff that we have discovered as a result of scanning IP addresses. This is more things that you configure as a user of the product. And one type of metadata are person, records of people. Maybe they're users of the system, actually. And look, there's me down there. So I just have a name and a username at the moment. So just remember that. As I say, it's a silly example, but I'm trying to keep it as simple as possible without any distractions of thinking about the types of records that we've discovered. If we go back to the knowledge page, hopefully that upload is finished. Yep, fine. So that upload is finished. In fact, if we search for it, I call it demo. I called the module name demo there. So that the pattern that you just saw in my editor is now in the system, and it's sitting there ready to trigger on the receipt of an event. So let's send in another event and see if we can get it to trigger. So we'll go back to our command line, and we'll interact with the API again. So remember, it's a post request. We always need this header. So we had the event source, which will keep the same. We need the type, which we saw. If we set it to SetMessage, our pattern should trigger because it only looks for events of that type. And now we need to pass in the data that the pattern's looking for. So that was a username field and it was a message. But how exactly do we do that? Well, if we go back to the docs a minute, there was also this params. So this is a nested object in JSON, and it's open. You can put in anything you like here, any fields you like. This is really the core useful information that you're sending in. Your knowledge of a change in your environment gets packaged up in this params object here. So if we go back here, we need params. This is a nested object, and we need username. So I'll refer to my user that we just saw. We need a message too that the pattern can read. I'll use an old favorite there. There we go. So that's the full JSON body now. And we still need to target our endpoint. Let's just check that. So we've got another post request coming in, must be authenticated. We've got this event source, we've got the event type for the pattern to trigger on, and now we've got this params block. The event's going to contain two interesting fields, username and message, that we want our pattern to read. Let's give that a go then. So again, we got back an ID. Let's go back to the user interface. Let's go straight back to that person node. And now we have a new field that's been written to that person node. So I have a message field now on my record in BMC Discovery. And as we saw, that's as a result of our pattern triggering. Now, you might be asking, how did I manage to write this message field? Was I allowed to do that? What sort of database lets me do that? Well, as I say, it's a graph database that we have that's our model of the world, plus a little bit of this metadata, and it's schemaless as well. So you're free to write patterns that create new fields if you want. Although we do have a taxonomy that's sort of the known fields, and you can use that for reference, and it's what the user interface interacts with as well. So the pattern seems to have triggered, and if we go back and look at the event source, we've now got two instances of events that have come into that event source. And the most recent one, it stored the username field as well. So as well as storing the event source and the type, we see the username in there as well. So we now have we've now managed to go through all 3 stages of the workflow there. So this is just a silly example, as I said, but let's just reiterate what we've done. We've posted an event in this case we used a Linux client using curl. We posted an event into the REST API about something that's changed. In this case, silly example, but we were saying that the username and the message field were standing in for data about something that's changed. We had an event source that accepted the event, and we saw that it created an external event record in our system. And then the interesting bit is that we had a pattern that triggered on the event, actually on the event type specifically, and it updated the model that we hold. And in this example, we updated a field on a person node. So if that was clear at all, then that's really all you need to get your head around, those 3 stages of the workflow, and the fact that you have knowledge outside of our system of something that's changed in your environment, and you can push in that knowledge now, you can write a pattern to trigger, and you can get us to update our knowledge of the world. And the rest is up to you. These are the hooks that we give in this feature, and everyone's going to have slightly different things that they're interested in, things that are changing in their environment that are more important to them and that they want to push into BMC Discovery, and ways they want us to respond, and they can do that. These are the hooks. So you would typically, as I say, in your pattern update the big part of the model that refers to all the discovered software and services and hosts that we've discovered as a result of scans. But for this simple example, I was updating one of these person nodes. So what am I going to cover now for the rest of the webinar? Well, I've shown you the whole workflow, and we've shown you an example. And all I'm going to really do now is just fill in some more details. Maybe some of the things you've been wondering about around the event sources. I'll talk about that in a minute. I'm definitely going to talk about that vCenter built-in event source. What's that all about? And then I'll just finish up with the last demo. We're going to use PowerShell for that one. But that's it. That's what we've got coming up. So first of all, to fill in some of those details, I just thought it would be useful to talk about some of the existing features of Discovery that you can use as you're developing your pattern that's going to trigger on external events. So there's a couple of features here: provenance and manual pattern execution. Well, what do these terms mean? What does provenance mean, first of all? Well, as I say, as we scan your environment, we record all of the raw data. We call it directly discovered data that we find. So whether that's a list of processes that we're running, or it's a list of the outputs of other commands that we've run to get file systems or network interfaces, we record all of that. And we use that as evidence of our model of your software that you've got, and applications and services, and even evidence of the existence of hosts. So that if you're ever not sure, or you want to say, well, why does BMC Discovery think I have a Linux server running this particular software that's interacting on this port to this other piece of software over there on this other server, you can always drill in and find out. And we call that whole feature provenance. Let's show you an example here. So this is the quick search up the top here. If I search for Apache Web Server, there's a whole load of different types of records. Remember, we call them nodes in the system. I want to look at the software instance. So in this instance of BMC Discovery, I found over 60 different running Apache web servers, a whole load of them there. If I just pick one here, this particular instance of Apache web server we're looking at now. We're looking at its page in the web UI. Well, you get a nice visualization of it and the interactions it's got with other applications in your environment, and then you get a tabular form of information about the software. But why does BMC Discovery think that this software is running? Well, if we go up here, there's a Show Provenance button, and you find this on most of the pages when you're looking at the data that we've discovered. If I go down now, we have this grey block here. So this is the provenance, or the evidence for fields on the left here. And particularly, let's look at this, the primary data provenance. So the main reason that we think there is an Apache web server on this particular host is this, and it's this discovered process. So if I click through to that, so we found a process with this name and these arguments running as a result of getting a whole list of processes at this particular time, and it was when we were scanning, keep clicking through, this particular endpoint which we scanned here and we finished here, and as a result of scanning this endpoint we inferred this host here. So this just gives you a quick example of how you can drill through the evidence or the provenance of why we think that your environment is as we're showing it back to you. But it doesn't just work for data that we've found as a result of scans. It also works for changes to the model as a result of events. So if we go back to that person node that we updated, and the provenance setting is still set on, and look, that message field that we wrote, it has a provenance link here. And so that message field was set to this value because of this external event record. And if I click through, we're back to that event record I looked at just before. So this event record comes into the system, and that is the reason that BMC Discovery set that message field on the person node. So I'm just showing you it's linked up. Provenance feature works even if we make model updates in patterns as a result of events. By the way, all this linking up and provenance happens for free when you change models in patterns, where we're keeping track of everything that's changed. Right, what was the other feature I talked about? It was manual pattern execution. And what that means is, well, you are working on your pattern and you might be changing it. So we've got our pattern in the system here. Let's find it. There it is. That's the pattern we uploaded, but I might want to make a change to it. So you remember that the pattern at one point here, it has to extract the message field from the event. What if I wanted to do this? There's a built-in function called text.upper. Probably guess what it does. And I'm going to pass in the message field from the event to text.upper. So I'll uppercase the message field. If I save that change, the pattern is now going to be recompiled. So I've changed slightly the body of the pattern. The pattern triggers on events. So how am I going to test that? Well, I can only test it by getting another event into the system. Well, if I was writing a pattern that triggered on a discovered process, which as most of the patterns typically are actually, then you're going to have to do another scan, and that's not always desirable or possible. And so we have a way you can run your patterns that you're developing against existing data in the system, and we call it manual pattern execution. So in this case, we want to run our pattern. Let's find it again. There it is. So actually, the pattern's a version. So the old version without the text.upper is now inactive, and we have a new version there. Let's have a look. There it is, text.upper. So I want to run this new version of the pattern against that event record that we have and make sure it works. Well, what we do is we find the event record here. We're going to do something called adding it to a manual group. I'll explain why in just a minute. So we'll call it webinar group. Now, if I go back to my pattern, there we go. This is the pattern record here. So I want to execute this pattern. So let's run the pattern. So as I say, I want to run the pattern against some existing data. And the way you do it is you, first of all, gather the data that you want to execute against into what we call a manual group. And normally, if it's some discovered process data or a host or some software, you'd bundle it up into a group and then you'd select your group here. Well, you just saw me put the event in because that's the data that I want to pass into the pattern. So let's run the pattern. So the pattern's run. It's already output something. You might have noticed there was a log line in my pattern, and it looks like it's managed to uppercase things. So the pattern's finished. It's a very simple pattern. It's very quick to run. And we can go back and check that poor person node that we keep changing. And now the message field is uppercase, so we've set it to hello world again. So that's just to show you that the pattern, manual pattern execution feature works just as well with patterns that are dealing with events as patterns that are dealing with discovered data. Okay, so there's only a few more things I want to fill out around the details of events, and then we're going to talk about that vCenter event source. And the last things are here. So event sources and event types. This may be slightly confusing right now. So we had to create an event source. Remember, that's that middle stage of the workflow. You have to point an event at an event source when you're sending it into the system. But then we have event types, which were the field in the event that the pattern triggers on. So do we really need both of these things? Well, let's have a look. Go back to our event sources. So there's our webinar event source. Now, event sources, the way to think about them is they are a unit of management of events in the system. They're a way of saying whether your events are allowed to go in and a way of tracking them. I mean, we can see the tracking part of it already here. We've had 2 events come in that were targeted against this event source. You might have a number of different integrations talking to the API written maybe by different teams that are interested in different changes in your environment. And it's probably easier to manage that by having an event source specific to each integration. Now, the event type is not bound to any particular event source. As you saw, the pattern talked about an event type, and it triggers on an event only when it's got a type that it's looking for. But the pattern didn't mention the event source either. So the pattern will trigger regardless of which event source you targeted at your API call at. And we can see that actually. If we create a second event source now, the first one we called webinar, the next one we'll call webinar_2. There we go, we've got webinar_2 with no events have been sent in right now. If I go to the command line here, first of all, why don't we try and send in an event targeting a source that we know doesn't exist. Instead of using webinar, we'll just use this name here. Right, what happened there? We got back an error from the API. Remember, it's a REST API. We use HTTP response codes. In this case, the code 400 means invalid request, and there's the details, invalid event source foo. So you have to send in an event to the correct event source. So again, the event source is a way of managing events, and as the administrator of Discovery, if I decide I don't want to accept events anymore from that integration, I could delete it. But let's send in an event to a valid source. Let's send it into the webinar 2 that we just set up. There we go. Let's also change the message so we can see if it's actually had an effect. There we go. So that seems to have worked because we got back an ID for the event. If we have a look here, the webinar 2 event source now has received 1 event, as you'd expect. Let's look, the record of that event. It stores the event source and the event type as always, and the new message we sent in. And did the pattern trigger? Well, there's the person node, and yeah, it did because the message field has been updated. So the point is that event sources and event types, they're orthogonal really. The pattern is just interested in the event type, and you might have events of the same type coming into different sources, or you might have events of different types going into the same source. Whereas the sources are the unit of management of events. And you can, as you see, you can track the number of events, and you can reset the count of events. Look there, that you can disable a whole event source. If I do that, so webinar 2 is now a disabled event source. If I try and send in another request to webinar 2, I got back not an error but an empty string. Well, that's okay, because if we look at the docs for that endpoint, it returns an empty string if the event source has been disabled. Right, so we've covered disabling event sources. Really, the point is, event sources, unit of management of events, event types, a way to trigger your patterns and to narrow them down just to events that they're interested in. Now, the final thing on here is really something that not to do. So if you knew that something had changed in your environment, you might think that what you really want to do is to trigger a scan, trigger BMC Discovery to scan maybe the server that's changed, or a whole range of addresses that you know have servers that have changed. Well, probably, in fact almost definitely, events are not the feature that you want to use to accomplish that. Now, it would be possible to go and use the REST API to do stage one of the whole workflow and post an event into the system, and in the body of in those params fields in that event, you could maybe encapsulate the IP address range. Then you could have an event source, obviously, for stage 2, and for stage 3 you could have a pattern you've written, and you could trigger on that event. And it is possible, there are methods in the tuple language to initiate a discovery scan from a pattern, and it could read the address range to scan from the event parameters. However, there's a big caveat with all of that, which is that from a pattern you can only scan addresses that have previously been scanned in the system, and that's done for control reasons, to make sure that people don't accidentally upload patterns that then go off and scan everything they're not meant to be scanning. And as the administrator, I think you'd want the control of that. There's a way to, you can only go and rescan existing things that you've previously been allowed to scan, because there's a whole load of exclude ranges and control over what address ranges are allowed to be scanned or not in the system. And anyway, that's really complicated and convoluted to try and create events and upload patterns if all you really want to do is scan an IP address range. There's a much easier way to do that. Let's go back to the docs again and back to the list of endpoints in the API, and right up the top, remember, there's this post discovery run that adds a new run. And so this is how you talk to the REST API and say, look, start a new scan here. So you can pass in a label, and you can pass in a range of IP addresses. You could also start a cloud scan here, but I'm not talking about that right now. In fact, why don't I see if we can show you that. So let's send in a different request to the API. So we saw that that was a post request again. As always, it needs to be secured. And then the payload, so we saw that it needs a label. Also needs let's just show you the docs quickly. It needs a ranges field here, and it's a list of IP addresses or a list of ranges. So what we'll do is we'll pass in that's our test network here in London. There we go, and as always I need to target an endpoint. There we go, so just checking that, we've got another post request again with the token for security. We've got a label field there, we've got a ranges, so a list of ranges, just one range actually here, and we're calling the discovery/runs endpoint. Okay, so we got back a JSON object with two fields, a unique ID of the scan we've just created and a link to an endpoint we can use if we wanted to track the progress of that scan. Well, actually, let's just use the user interface. So if I go to Manage Discovery here, there you can see there's our scan started that we just sent in, scanning that range. So that's how, if you wanted to ask BMC Discovery to scan an address range, you just use that endpoint. You wouldn't go through the convoluted route of event sources. So that's it really, to fill out the details of events. That's I'm not going to talk any more about any other things. I think we've covered everything around the details there. And before I finish up with the last demo, I'm just going to briefly talk about the vCenter event source, which you saw in the user interface there. Because it turns out that there's actually quite a nice example of something in your environment that might change more frequently than you're scanning your environment. And that is virtual machines, and virtual machines moving around from host to host. Because BMC Discovery, we obviously find both your physical and your virtual machines. Typically people have a mixture of both, and we link up virtual machines to physical, and our model of the world shows you what hosts virtual machines are running on. And we can discover using different virtualization technologies, it doesn't matter. But sometimes virtual machines can migrate from one host to another. So under VMware, for example, you a virtual machine can go through what's called vMotion, where without it being shut down from the user's point of view, it can be a whole image in memory can be moved from one host to another. And that's fine, but as soon as that's happened, our model of the world is now out of date until we next scan, and maybe we'll scan very shortly afterwards. But if you know that that vMotion event has happened, and it's not just on VMware, this can happen under other technologies as well. I think it's called live migration in Windows. But anyway, this is talking about VMware here. If you know that that's happened, it would be nice to be able to push an event using this whole framework into BMC Discovery and tell us just to update our bit of the model that is the linkage between virtual machines and the host that they're residing on. Instead of waiting for the next scheduled scan that hits those virtual machines, and indeed, instead of initiating a whole new scan, because you know exactly what's changed in your environment. Well, it turns out that you don't need to do that at all, because we thought that was such a common use case that we implemented that for you. And that's why you see something built in there. So as of version 11.1 again, there is a component inside BMC Discovery that can talk to vCenters. So if you're not familiar, vCenter is the part of the VMware technology stack that manages a load of different hosts that themselves are managing virtual machines. But the vCenter, the vCenters can tell you of their own events. So just to avoid confusion here, vCenter events are events of things that have changed around the whole virtual machine, all the virtual machines that are being managed. So we have a component now that can poll vCenters. It only polls vCenters that we've previously discovered. And we can ask it, hey, what's changed? And if we find a vMotion event, or actually a few other events of interest have occurred, then what we do, our component, is it creates an event targeting that built-in vCenter event source. And then we have built-in patterns that trigger on, say, the vMotion event and that update our model of the world. So the vMotion event will contain the old host and the new host, and we'll update the linkage in our graph database model. So we go through the same three stages, really. We create an event, but we don't go through the REST API because we're already inside our appliance. We have an event source that we target, but it's not one you created, it's one that you get for free. And we have a pattern that triggers and updates the model of the world, except you didn't need to write it because we give it to you for free. Let's just have a look at that. So back to the event sources, and there's the built-in vCenter event source. So I actually don't have any events because this demo appliance hasn't been scanning any vCenters. But if it did, you'd see the events that have been created here in the same way as for the other event sources that we've created. So by default, actually, it's worth pointing out that this whole mechanism of polling vCenters is disabled, so you need to actively go in as the administrator and enable it. And in fact, you can configure it and enable it or disable it on a per vCenter basis. But it's the same, under the hood, it's the same three-stage workflow. That's the point I wanted to try and get across. But you don't need to write it. If the thing that you're interested in is getting BMC Discovery to respond in a timely fashion to vMotion events or other events from vCenter, then you get that for free. And we can probably just find the pattern that we give you as well. If I search for vMotion, there's some patterns, and I think it's that one. Here we go. So this is one of the patterns that we give you out the box. And look, it triggers on an event like the one we were writing. This time the event, though, is a vMotion. There's a few different names for the different flavors of that migration event. And what it does is it then calls a helper function here that we've written, but it all boils down to updating our model of the virtual machines in your environment. Okay, so that's the vCenter event source. And I'm almost done, actually. I just wanted to finish up with one last demo, and then we'll see what we've learned. We'll summarize what we've learned. Here we go. So for the last demo, I'm going to be using something called locations. So again, back down here, the metadata. So not stuff that we've directly discovered or as a result of a scan, but stuff, things that you can configure in our system. So remember, we've discovered a whole load of hosts as a result of scanning your environment. And we can discover the flavor of the OS and all the packages that are running on those hosts. as well as the makeup of the file systems and the network interfaces, and then all the software and everything up as you go up the stack. But sometimes, well, we can't often know out of the box where the physical location is, or what the physical location is of the servers that we're discovering. We don't know the rack and the data center that they're in. But often that's really useful information, and it would be useful to get that associated with the host and see it in the Discovery user interface and anything else that interacts with our data. And so, way before we gave you the events feature, it's been possible to configure locations. As you see here, I've got a few locations configured. Locations that you might find hosts in your environment, and then it's been possible to customize Discovery to make associations between hosts and locations. And the way that you typically would have done that is you would write a pattern that triggers, and that triggers on the discovery of a host this time, not of the discovery of a process, but as every time we discover a host. And then the pattern, well, then the thing it does is it really depends on your environment. So some customers have a naming scheme for hosts. In that case, the pattern can go and run a regular expression to extract the physical location from the name of the host, and then it can link these location records here to the host. Maybe you have a file in a known location on every host, and then the pattern can go and read that file, find inside the file, find the physical location, and then, again, link the host to the location. Some people have an external database, and then patterns can be written to access that database, look up the host, or maybe it's a Windows machine and you have used the registry to store the location. Whatever it is, the pattern is your hook to find out the additional location information and make the linkage between hosts and locations. So I thought for this last demo, I'd try something. What if you knew outside of Discovery that a host had changed location, and you wanted to send an event in and get BMC Discovery to update its model of that host by changing the location? So there's a particular host I have in mind to target here. So here's all our hosts. MCR SnapDev. SnapDev1 is the host I'm interested in. So here's a record of the host, and there's a location that's already been filled in. So this host is currently, so what we'll do, we'll just remove the provenance field there to keep it nice and simple. This host is currently residing in location London Data Center 1. Well, what if we knew that it had changed to Data Center 2? We wanted to send an event telling Discovery of that change. Well, we need a pattern. So here's another pattern I've written called update host location. So this pattern is going to link a host to a location. So as always, it triggers on an event. This time, it's a different event type I've decided to use, set host location. So we need to send in an event with that type. And the pattern, what's it going to do? It's going to look at that event record, and it's going to extract a field called host name, and then it's going to search our model for the host that matches that name. If it finds that host, it will then extract another piece of information from the event. It will extract the location field from the event. So the event better have a host name and a location field. And it will then search the metadata for the location record that has that value. Well, fine, we saw that there was an LDN2 there, you might have noticed that. If it finds both the host and the location, it will make this call here, which all it does is it links those two records up in our graph database. So it links the host to the location. So let's upload this. We go back to the knowledge page and we upload this pattern. Set host location. Right, so while that's uploading, I thought that for this next example, for this last example, I wouldn't use curl, so I'd use a Windows machine, so a Windows client to the REST API, because for those of you that are more based on Windows, you might not be using curl, but you might well be using PowerShell, which is the Windows scripting language these days. So I've created a PowerShell script here. It's a short script. You can see it all on this one page here. The interesting bits at the bottom here, it calls this built-in command let's invoke REST method that's just targeting that same events endpoint, API v1.1/events. It's got the headers in with the token that I've embedded. This would typically be embedded in if you're writing a script like this. And it needs to send in the JSON body, and there it is. So I'm targeting the same event source we've been targeting all along. I've got the different type there, so I've got the same string that the pattern's going to trigger on. And we saw the pattern needs a host name, so I've put in my host, and it needs a location. So I'm saying this host has moved to the LDN2 data center. Let's just check that. There we go. So our pattern has finished uploading. So now we'll just go to this command line, which is my Windows command line now. We're going to PowerShell. And we can just run that script. There we go, and looks like it's worked because, like in the curl example, you get back a ID of the event record that's been created. So let's go here and let's have a look at that host. There we were. So we go down here to the location field, and yeah, it's been updated to London Data Center 2. And if we just check with the provenance view there, its location field is set to Data Center 2 now because of this, and that's the event that we've just created. Let's have a look. Yep, there's a record of the event that I've just sent in from the PowerShell script this time. Host name and location fields are there. And another way of looking at the event is to go to the event sources, and I targeted that webinar event source. Well, now there's 3. You might remember there was just 2 events that have come in. If I have a look here, so there's our first 2 events with the type SetMessage, but there's our one we were just looking at with the set host location. So just to point out really that, you know, PowerShell is just another one of the many client environments you can use to talk to our REST API. So I'm pretty much done now, I think. I've been reiterating again and again that there's these 3 stages of the workflow, and that's all you need to understand to get the concepts of event-driven discovery. Number 1, you push your event into the system, and your event is your encapsulation of a knowledge of something that's changed in your environment that you want to tell BMC Discovery. Stage 2 is the event source, which you've configured nice and easy, and that accepts the event. And stage 3, a pattern that you've written and uploaded to the system already. That pattern triggers on your event, and it makes a change. It updates the model. It updates the model that we hold of your environment in some way in response to that event. And we touched on the vCenter event source, and you get that one for free. So really now it's over to you. I'd be really interested to hear any ideas or things that you think you could make use of the event feature with. I mean, everyone's going to have different environments and different things they're interested in responding to. We have a pretty thriving community, and you can post on there. There's a link to the communities. If you've got ideas or questions about events, ideas about ways you might want to use the feature. There's also some links here about that other REST webinar and some of the docs pages I've been showing. So that's really it for me now, and we're going to go over to questions now. So thank you very much for listening to me.
Great. Thank you, Tim, for the awesome presentation. And now we're at the Q&A portion of the webinar. And Jennifer, can you give directions for our callers to signal you for questions?
Yes, and if you'd like to ask a question on today's call, that is *1 on your telephone keypad. A voice prompt on the phone line will indicate when your line is open. Please state your name before posing your question. Once again, that's *1 to be placed into the queue. And as a reminder, that is *1 for questions. And at this time, there are no questions in queue.
Tim, there was one question that came in via chat about do other BMC products, specifically ROD, BNA, or BSA, offer APIs currently?
Well, I don't know.
To
might be able to
Discovery.
comment on that. Yeah. Oh, offer APIs similar to Discovery, was that?
I'm assuming it's in relation to Discovery.
Oh, well, maybe Duncan can comment on what APIs are out there, but I'm not sure right now.
Hi, yes, this is Duncan. I'm the architect of BMC Discovery for people who don't know me. So, yes, to answer the question, it's slightly unclear whether the question means with regard to Discovery or just in general. So, many BMC products do have APIs. The Remedy suite of products have have APIs both for data access and for managing the system, so you can update data and with Remedy, for example, you can create incidents and so on using various API schemes. The BladeLogic family of products, so BNA and BSA, both have direct integrations into Discovery, so they can use Discovery's APIs in order to extract data from Discovery. None of them currently use Discovery, the event APIs that we've been seeing here, but certainly many products are able to connect to Discovery in order to get data out of it. And obviously, we also have an integration in the other direction that Discovery pushes data into the CMDB, the Remedy CMDB, and many BMC products and third-party products make use of that data once it's in the CMDB. All of our APIs are documented in the docs, so the same way Tim was showing the docs page for Discovery, there is a unified page in docs, which hopefully you can find with search, or we can send a link later, that lists all, or at least a very, very large number of the APIs for many BMC products. And so there's a unified page of APIs for products if you want to be able to script things, and certainly it is valuable to be able to script. You can write your code. So Tim's PowerShell example, it could maybe have talked to the BSA API in order to get information out, in order to push in an IP address to scan in Discovery. So those things are enabled. That we can send a link round to the unified page of APIs.
Thank you. Operator, is there any questions queued up at this time?
And at this time, there are no questions.
Okay. We'll pause for a few moments to see if there's any questions.
We'll go to our first question.
Hi, this is Steve, and I had a question regarding troubleshooting the methods. I don't have a lot of familiarity with building REST APIs, so what troubleshooting is available to kind of troubleshoot the code?
Hey, Steve. So are you talking about when you're just sort of interacting with any endpoint in our API in terms of troubleshooting your client's scripts, nothing specific to events here? Is that what you're talking about?
Yeah. My familiarity is really with the Atrium, the integrator. So looking at this, it's just different from what I'm familiar with.
Okay. Well, so maybe so going through the stack of those, again, those three stages of workflow, right? Let's see. The first thing you need to be doing is sending an event to API. Well, what could go wrong with that? You might get your token wrong. You might not be authenticated. All that stuff you get back with all that stuff is indicated with the appropriate HTTP response codes. And yeah, you could look at the docs pages as well for examples, and look at the webinar to get some examples of handling errors. But yeah, all of that stuff is indicated with response codes. If maybe your payload that you send in, when I put in source there, I'm not showing right now, but when I put in the event source, you saw that if I put the event source as foo, something that didn't exist, well, it gave me back a fairly nice error message. The same sort of thing would have happened if I'd have missed one of those mandatory fields out. So we try and make the errors messages as clear as possible from the API point of view. Then you've got, once the event's in the system, you can see stage 2 because the event source is showing you all the events that have arrived. And then you've got, well, why is my pattern not doing what I thought it would do? Maybe the best thing there is that manual pattern execution feature that I showed you, because that lets you execute the pattern as many times as you want. And typically people will have development instances of BMC Discovery that they might have backed up from production and restored in, that they don't mind playing around with so much. So you can run your pattern again and again. And you saw actually an example that I had a log line in my pattern there, so that I was, typically, as in a typical classical debugging method as it is to do logging. And so you can run the pattern, you can get your log lines in if it's not for some reason updating the model as you'd expect it to. Does that answer a little bit of what you were? Oh, one more thing actually, on the REST API front, just in general, although it's not published yet, hopefully coming very, very soon indeed is a new page on the docs with some example scripts, end-to-end example scripts in PowerShell and in Node for talking to our API. So, end-to-end ones, including error handling as well.
Okay, great. Appreciate it.
We'll go to our next caller.
Yeah, hi, Duncan. This is Abhijit. Just wanted to know that the REST API is only working with HTTPS, or can it also work with HTTP?
So by default, the API only works over HTTPS, which makes sense, and that's definitely the thing that we advise using in production. You're sending the data that you're sending and receiving back, is the data that you're viewing in the user interface. So just in the same way that if you're really worried about security or concerned mildly, you probably want to have HTTPS set in your user interface. So yeah, by default, out the box, you can only access it over HTTPS. And in addition, you need to set up users that can access it for these integrations, like the script that we just saw running. But it is possible for development purposes to enable via HTTP. You get a big warning when you do that, and we definitely don't recommend that for production use.
Okay, thank you.
Thank you for joining this month's webinar. We will be posting this webinar within a week of today's live presentation, along with the Q&A. And as always, here is information for contacting BMC via the social mechanisms, as well as BMC technical support via web, phone, and email. At this time, our webinar is now over for this month, and I want to thank Tim and our panelists for a great presentation. And thank you for joining this month's Connect with Remedy.